Hi, everyone, and welcome to the Cove. My name is Haley Young, and I'm an assistant director in the new venture group here at UCI Applied Innovation. It is my pleasure to welcome today's Lunch and Learn speaker, Haas Patel. Haas is the founder of InfoLogic. Before founding InfoLogic, he worked for Bell Laboratories, GlaxoSmithKline Pharmaceuticals, and BP Chemicals. His industry expertise includes aerospace and defense, pharmaceuticals, energy, and software. Haas holds an MS in production engineering and a BS in mechanical engineering, and his research interests include manufacturing and innovation. He has developed innovation management methodologies and has published several papers on these topics at defense and corporate R&D management conferences. He also serves as a member of the Advanced Manufacturing Partnership Southern California and represents InfoLogic in the Clean Energy Smart Manufacturing Innovation Institute. Haas is here today to present the fourth industrial revolution. Are you ready for it? Welcome, Haas.
Thank you, Haley. Thank you. Can you all listen to me? Okay. Today is the National Manufacturing Day. And over 3,000 events are organized by academia and industry throughout the country. So this event is a part of the national celebration of advanced manufacturing in the United States. Today, in specific, we'll discuss how manufacturing and hardware-based innovation can help startups to thrive. So thank you for joining us. These presentation slides will be posted on the Cove website, and also I'll be taking the questions at the end of the presentation. So let's get started. The society and all its sectors, including the state, the civil society, and the market, are being disrupted by technology. And these changes are going on at a very accelerating rate. And they are being brought to us by the fourth industrial revolution. So what is the fourth industrial revolution? And how can it help us? How can it help the society? Let's explore. So how this fourth industrial revolution can help us? These are some of the ways the past industrial revolution has helped us. The industrial revolution, the first one, it was powered by water and steam. And that gave us more physical power. We can do more with less energy. The second industrial revolution, powered by electricity, gave us mass production and automobiles, which gave us leisure time to explore suburbs and also outdoors. The aeroplanes gave us the ability to explore the world. The third industrial revolution, which was powered by computer and telecommunication technology, gave us productivity. We can get knowledge through internet instantly. And the fourth industrial revolution is going to augment our intelligence, is going to be much, much more powerful than the previous revolutions. So how this revolution will help the society. So let's explore that. And why it's happening. The first reason this industrial revolution is very fast moving is the cost dynamics. As you can see, the phone which is in my hand has more capabilities than the space systems of 60s and 70s. Now, this cost dynamics is leading us to exponential pace of innovation, which is transcribing the industry sectors and also the national borders. The autonomous vehicles, which are nothing but computer and communication systems on the four wheels. So what is the industry sector for autonomous vehicle? Is Tesla a tech company or is it an auto company? Regarding the industry borders, the Apple Corporation is regarded as one of the largest manufacturing companies in the USA. However, it only manufactures 0% of the product. Most of its products are manufactured in China with components from South Korea, Japan, and some components, of course, from United States. But the components sourced from United States are also integrated and assembled in China. So, exponential growth of technology on industrial borders and also different countries is leading us to exponential advances in technology. And these are the technology which are fueling the fourth industrial revolution. And those of us who are regularly checking the advances happening in these sectors know that those advances are completely going to change the society. So, the cognitive capabilities, we already know about cognitive capabilities. The autonomous car vehicle, software which talk to us, and the physical, digital, and biological worlds are no longer a science fiction. These are some of the examples in last 2 weeks. And I'm sure many of you have also experienced similar example. So this revolution is not technological revolution, it's really a societal revolution. And it's going to impact all components of the society, the state, the market, and also the civil society. It is possible that there may be market-oriented changes and which will give us productivity and efficiency, and it will only benefit the people who have intellectual capital and physical capital, like investors and the people who can take decision in venture capital industry. And people who only have a labor, they may not benefit from that. On the other hand, we might get safer and better jobs for everyone. So no one knows where the future is going. But we cannot wait for the future. We need to plan for it. Those countries and societies which have planned the previous revolution, they have obtained the benefits. And those nations and society which haven't planned, they have seen their lifestyle and other national resources go under. So, how we in the society should plan about this particular revolution? As I said, it will impact all components of the society, from state, the market, to the civil society. But today, we're only going to concentrate on the manufacturing, a subsector of the market. So you ask me, why manufacturing? Manufacturing represents a critical component of American security and prosperity. And it's also part of the American innovation ecosystem we all represent here. 70% of R&D spending is conducted by US manufacturers. They also produce over 55% of the patents. And 60% of the export are done by manufacturing companies. So it is a very important part of American prosperity and national security. In particular, regarding the national security and prosperity, US Department of Defense has a special policy on defining the industrial policy. In fact, if you follow some discussions, 2 weeks ago, a report was conducted by Department of Defense, and they found that we need to have a significant heavy investment in defense advanced manufacturing sector. And while we are talking here at the White House, President Trump and the Secretary of Defense are signing into laws a number of parameters which will help us to increase advanced manufacturing in our defense sector. Deloitte Corporation recently conducted a study of the different scales of people within the United States. And based on the survey, they found that 83% of American people feel that manufacturing is responsible for economic prosperity. 81% for standard of living, 62% for national security. So if manufacturing is such critical for our national security and prosperity, let's examine the state of American manufacturing. Some of you may have known that in last 2 decades, with American manufacturers' policy of invent here and manufacture there has resulted into a number of losses in our industrial jobs. So let's explore these losses and what are the opportunities we might have to correct this. So what will it take? What will it take to make sure that advanced manufacturing flourishes in this country? Recently, 2 prestigious American organizations conducted a study to understand the strength of American industry and as a nation fueled by the 4th Industrial Revolution. The McKinsey Corporation conducted a study in conjunction with CEOs of all major companies and also took input from stakeholders in government and academia. And they mainly concentrated on the strategies which the corporation should be adopting. The Deloitte Corporation, again, conducted a study, but they mainly concentrated on the manufacturing technology and the impact of 4th Industrial Revolutions on the technology growth. So both studies identified that though America lost basic manufacturing capability in the last 2 decades, there's a sun rising for America due to a number of strengths which America has fueled by the 4th Industrial Revolutions. So the first strength, the technologies which underpins the 4th Industrial Revolution in which United States is leading. Artificial intelligence, autonomous vehicles, 3D printing, advanced materials. Second, technology conversions. We all know that IoT is generating the data which is stored by cloud and processed by artificial intelligence software, and it is presented to the people with augmented reality. This needs high-end integration skill, system integration skill. America has this strength. Think about our defense programs and our space program. They're highly complex system integration project. And this America's strength will allow us to build factories of the future based on the technology generated by the fourth industrial revolution in the United States. The third one is emerging in a home market. United States represents the most profitable market in the world. And as predicted by McKinsey Corporation, by 2025, the emerging markets consumer requirement will be $125 billion, up from in 2010, approximately $12 billion. So this is a huge market for America to go after based on America's strength. So even Deloitte Corporation recently conducted a study. They conduct this study regularly to understand competitiveness of manufacturers throughout the world. In that latest study, they compare 5 drivers of innovation which are listed on this slide. They found in the latest study that United States will take over China by 2020 for its competitive manufacturing index. It means that if any company in the world want to decide where to manufacture, United States will stand at #1. Now there's one deficiency we have too. Even in 2020, as you can see from the chart, the size of the circle represents advanced manufacturing exports by different countries. In this regard, China and Germany will still lead us. However, if you say that, look, we will lead manufacturing cost competitiveness by 2020, so it is possible that the worldwide manufacturing industry, when they're thinking of starting new plants and expanding, on a competitive level, they will also consider United States for their manufacturing factories. So these parameters will significantly help us to attain #1 manufacturing location in the world. To achieve this, we all, as a part of American innovation ecosystem, has to play a part. So this is the American innovation ecosystem. It has all the stakeholders from R&D to technology commercialization. So that includes all the R&D labs, decision makers from government, academia, and investment community. And some of them are also foreign actors who are playing part in our American innovation ecosystem. So how we all, as a part of American ecosystem, ensure that we take advantage of the opportunities which are being brought to us in advanced manufacturing by the fourth industrial revolution. So let's explore this. To understand this topic, the granddaddy of America's innovation system, the National Science Foundation, recently published a report on the state of our manufacturing R&D capabilities. So in this report, they conducted a study by holding approximately 5 roundtables throughout the country. And during this roundtable, they invited CEOs of large manufacturing companies and also stakeholders from tech companies, government, academia, and American think tanks. And these are the 4 topics they discussed during those roundtables. Industrial commons. We all know that we have lost our advanced manufacturing capabilities. So how does America bring back those advanced manufacturing capabilities to the United States? 2, after the 2008 financial meltdown, American manufacturers also followed another mantra, which was invent here and manufacture there. From there, they changed to invent there and manufacture there. So they moved a number of R&D functions to other countries. And that has negatively impacted our R&D capability. So National Science Foundation asking, how can we conduct more R&D in the United States? And in addition to reshoring manufacture, how we can reshore R&D back to the United States. The next component, if we have to develop factories of the future, we have to develop more hardware-based startups. And we need government support for hardware-based startup. And the next one, of course, is capitalize on national R&D. United States spends $150 billion for federal R&D. It's a very huge amount. So how do we make sure that we commercialize that R&D? A small percentage of $150 billion of investment is commercialized by industry. So how do you do that? At the same time, they identify two major concerns in R&D sector. This chart is produced by R&D magazine every year. And let me explain to you, it's a little bit complex, but let me explain to you. The x-axis represents GDP of a given country. The y-axis represents number of scientists and engineers per million people in a given country. So let's take an example of United States. The total worldwide R&D budget expected in 2018 is about $2.2 trillion. And United States spends approximately, or will spend in 2018, about $550 billion. This includes both industry, academia, and government. So that represents approximately 26% of worldwide R&D spend. And another component is that this R&D spend is approximately 2.8% of our GDP of approximately $20 trillion. So that's how this report is done. And the size of the circle represents in PPP dollar, absolute PPP dollars spent by each country. So what are some of the takeaways from this particular report? One, worldwide, 75% of R&D is conducted by manufacturing. So R&D and manufacturing are two sides of the coin. If we lose manufacturing, we lose R&D. If we gain back R&D, we gain back manufacturing. Second component. During the last 15 years, Asian countries have accounted for a higher percentage of R&D spend. And this is due to two reasons. Number one, those nations, China, South Korea, Japan, and to some extent Germany, they realized at the national level that R&D and manufacturing are extremely important for their national security and also prosperity. So they're increasingly spending more R&D in manufacturing area. The second reason is that, which I briefly introduced, after 2008 financial meltdown, American companies accepted this mantra of invent there and manufacture there. So some of our R&D dollar also went to countries outside USA, mostly within Asia. So this had negatively impacted. So NSF is asking, how can we correct this thing? And the second topic which NSF identified is this. We all know that American venture industry is world's most vibrant. And we all know that it makes a significant difference in America's prosperity. However, according to the report, American venture industries invest a very small percentage of their huge portfolio in hardware-based innovations. And the reasons are understandable. They feel that hardware innovation and startups needs large amount of capital, and it takes a long time for them to get that money back. However, overseas countries, mostly Asian countries, they spend much more percentage of their R&D outlay on hardware innovation. In fact, the China's Shenzhen district is called the Silicon Valley of hardware. So they are spending money on hardware innovation, and our country is dependent on advanced manufacturing. Why don't we invest more money in hardware innovation? Why doesn't our innovation community, the venture community, invest more money within the United States on hardware innovation? This is the second topic National Science Foundation recognized. So based on all these surveys, they made a number of recommendations. One, and these are the national policy recommendations: invest in transnational research and manufacturing innovation. So they are suggesting to the federal government that we need to start transnational research institutes where hardware vendors and hardware startups can flourish with government help and auto industry help. Second thing, encourage pilot production by hardware startup and small and medium businesses within the United States. And we have precedent for that. Think about aviation. Think about internet. Government supported those companies with a heavy R&D investment, so they do basic research, and then those industry conducted applied research and commercialization. So we have done it before. And the next, of course, is the growing domestic engineering technical talent. We all know that we need more STEM graduates. And according to the report, they're advising that we should also ensure that the graduate who study STEM within the American university, they should be encouraged to stay in the United States instead of going back and starting businesses, hardware-based businesses in other countries. So now you may ask, after all this discussion, what are the strategies which startups can employ to make sure that they conduct more hardware-based innovations? The first one, leverage the American strength, which I discussed previously. Leverage our R&D. And when you are preparing even your investment proposal, make sure that you incorporate those American strengths in your business proposal and advise the investor as to how you'll be using this American strength in your own startup. In addition, explain to them that not only this American strength will be applicable to my proposal, but also it will make an impact at the national level on securing our nation and also giving us more prosperity. The second one, the fourth industrial revolution promotes local production, small batch production and customized local production. Think about 3D printing, and we have seen some example of that. So using the technology which are available for advanced manufacturing, we can do much more local production in the startup environment. And the next one is adopt emerging manufacturing platform. And I have listed these three here. So let's explore this platform, because these are the platforms, if startups include in their startup, that will significantly help them to ensure that their startups are successful and they achieve the benefits they are looking for. The first is the smart manufacturing. Smart manufacturing is integration of emerging IT technology with manufacturing operations technology. In the trade, it's called IT-OT integration. And also smart manufacturing enables you to ensure that the product you produce are based on providing more value to customer in terms of asset utilization and also in terms of ROI based on the fourth industrial revolution developed technology. And the third component is that smart manufacturing is based on software industry. And America has a strength in software industry. So we can leverage the benefits of being software industry in our backyard. So let's look at the next one. It's called system in a package. Around 1980, we lost fabrication industry. America lost fabrication industry because it was very labor intensive. So what happened is that industry, were designing here, but they were manufacturing using inexpensive, cheap labor outside the country. However, now the fabrication technology are emerging. So it is now possible using technology known as system in package and also system on the chips. You can develop a number of advanced manufacturing sectors in the United States. In fact, in about 2 weeks' time, UCI is hosting 16th Industrial System on a Chip Conference. If anyone is interested in that, they should go to Cal IT2. It will be held at the Cal IT2 and register for the conference. It's a 2-day conference. And if you're in the startup, you will also meet a number of prospective startup and also a number of industry people who can be your future customers, or you can sell your companies to them. So if you are in this field, ensure that you sign up for the conference. Next one is continuous manufacturing. As some of you who are in the pharmaceutical industry might know that most of the pharmaceutical for the last 50 years has been carried out or manufactured using a batch process. It needs very heavy equipment and a lot of money to maintain and purchase those equipment. Now, with a continuous manufacturing, you may develop medicine in a local environment, even in a prototype environment in your startup or in a lab, at a UCI lab or anywhere else. In fact, United States Congress recognized the importance of continuous manufacturing. So 2016, as a part of America Cures Act, I think it's called 21st Century America Cures Act, they authorized grants to conduct more applied research and commercialization of continuous manufacturing platform. So, if the startup decides to use all the strengths which are in American society and all the new opportunities being opened up with the advance of the fourth industrial revolution, how they should integrate in their own plans and policies. They need to develop an innovation culture in their product development process. So about 3 years ago, United States developed an American innovation strategy. So basically this strategy says is this: when you are developing product, do not only concentrate on hardware product development, but also conduct innovation into services, processes, and related business execution models. So, based on the American innovation recommendation, this is a suggested innovation management model which startup or small and medium businesses can adopt. So what it basically says is that instead of the traditional notion of technology commercialization, you should adopt a broader approach to innovation management when you are planning for your startup. And you should make sure that it should be multidisciplinary innovation, not only product innovation, but service innovation, process innovation, and execution innovation. And this innovation should be based on solid platforms. And here are 4 recommended solid platforms. To explain this model further, let me give you a case study. Apple Corporation has successfully inbuilt this multidisciplinary approach in their product development process. We all know that the phone in our hand is really a product innovation. It's a material-based innovation. To supplement this thing, they conducted innovation into services sector, iTunes. That's where the software is managed. All the supply chain for the software is done in iTunes. Also, to make sure that they have a vendor environment properly covered, they developed iOS app development environment. Without this environment, Apple would not have all the successful application. In fact, this app development environment is so successful that worldwide, now Apple has over 2.5 million app developers. And Apple takes 30% of each developer's revenue as that part on it. On the execution model side, they invented retail center as a knowledge center. You know, we all been to the stores before. We just go there and pick up the store. When we go to the Apple store, before we pick up the phone, we obtain the knowledge. And they developed a knowledge environment. And also Genius Bar as a center of excellence. And most of you may not be aware, but the distribution agreement with wireless carriers. This is a unique one. In that, Apple says that if you take my product and you incorporate in your network, I want part of the income which is generated by network. So it's like a manufacturer for home product like refrigerator telling electricity company that if you take my refrigerator and if you use your electricity, then I will take part of the customer's bill on electricity. So this is the first time Apple Corporation negotiated such agreement. So a part of the wireless carrier income is also received by Apple. So Apple would have just invented the product as the physical product, and they wouldn't have invented related services, processes, and execution model. It would not have become that successful company. So now let's explore some of the platform which I am showing in the middle of this package. Let's look at the first platform, the product market fit. We all know that for a successful venture and a successful startup, we need to make sure that there's a perfect product market fit. In fact, a number of people say that if you do not have successful product market fit, your product will not succeed. So basically, what it means by product market fit is this. You should not go and start looking for a new customer until your product has developed a prototype and you have validated that prototype with successful iterations and changes with input from potential clients. And there are a number of tools which you can use. And here I'm recommending two tools which are available in public sector. It means that it doesn't cost you anything. The first one is a tool called a technology readiness level analysis invented by NASA and very widely used by Department of Defense and a number of foreign manufacturing companies. And on the market development side, it's a Steve Blank's tool, and it's very popular in the venture industry. And what you should be doing is trying to develop a fit at a level which is shown by the red line. This is a little bit of a complex topic. So about 2 years ago, I gave a 1-hour lunch and learn on this topic as to how to conduct product market fit. So if anyone is interested, go to the Cove SlideShare site and put product market fit and put Patel, and you'll get that lunch and learn slide. And you will have a complete understanding of this particular model. So let's look at the next model. Once you obtain a perfect product market fit, and you have developed a notion of innovation into not only product, but product, process, service, and execution model, you're in a much, much better way to provide a better customer value proposition model. Here, as you can see from the two lines shown in the middle of the diagram, as you move from product as a product to product as a process to product as a service and a product as execution model, the value to the customers increases very significantly. And in the bottom part of the slide, I have seen some of the strategies you may add up to move from one value proposition to another one. And if you ideally develop product as an execution model, you'll have a much, much more value to the customer and your competition will decrease. So I encourage that the startup should scale this model down to their own market development programs. The next one is team science. STEM plus HUS is a team science. HUS is humanities and social sciences. Harvard Business Review said that for a successful product development, you cannot use only STEM people. You have to have STEM and humanities and social sciences. Why? STEM people make things work, but humanities and social sciences people make things matter to a customer. This approach has been successfully adopted by a number of companies. The Apple Corporation's views on this is well known. Steve Jobs told us, it's a technology married to humanities, married to social sciences, which produces the products which makes your heart sing. And the Apple phone designer integrated quite well in their products. And as we all know, that a 5-year-old child can use an iPhone with minimum instruction and can enjoy it. In fact, UCI is a very big proponent of such team science approach in product development. The Cal IT2 and Beckman Center has a number of projects where they use this team science approach. In addition, in June, UCI broke a ground for a 200,000 square feet facility for multidisciplinary innovation-based projects. And they'll be mainly team science-based projects. And this facility will open in 2020, and it will have STEM graduates, humanities and social sciences graduates, and facilities, and the large project to solve the humankind problem. So we have a lot of expertise in our backyard here. So I recommend to startups that when you are developing your products, please make sure that you consult humanities and social sciences faculty and also some students, and maybe use some interns from social science and humanities in your startup. So next one, but not least, is translational R&D. We all know translational R&D is moving discovery to the proof of concept products. Now, most of the startups based here and also throughout the country normally use university-based IP, and they try to commercialize it. However, as I discussed before, United States government spends $150 billion on R&D in their federal laboratories, which represents approximately 25% of the total United States R&D budget. And they have excellent facilities. So let's explore those. In the United States, we have about 250 labs which conduct R&D using the huge R&D budget we have here. And they have few advantages over academia R&D. One, they do not only conduct R&D, they also commercialize that R&D in their own internal program, maybe at the defense weapons programs or NASA space program. So they have significant expertise in the commercialization of federal government R&D. The second reason, once you become part of R&D created by a federal lab, you also have access to the end users. in the federal labs who are using that R&D. So they may become your potential clients too. Third one, in addition to R&D, they have developed significant about manufacturing processes. So not only you have expertise on R&D and commercialization, you have expertise on how to take some of the manufacturing processes and incorporate in your own venture. And the second federal government supported initiative, especially related to the advanced manufacturing. Got a few more. Can we progress, please? Okay. I'll do manually. Next one. Thank you. Oh, no, back. Okay. Let's stay there. No. Let's restart. That's it. Stay there, please. Thank you. Okay. So, United States government has developed public-private partnership to support advanced manufacturing. And each institute is either based on a given technology or a given process. For example, in Silicon Valley, there's an institute based which is for flex tech. And at MIT, there's an institute based on advanced textiles. They also have an institute based smart manufacturing here in Southern California. And they have another institute based on advanced design in Chicago. So the idea behind this institute is to provide a support to small and medium businesses and in particular startups. So I encourage you all to learn more about these institutes. In fact, as a part of that goal to support startups, they specially mandate that these institutes provide support to startups. Government funds each institute for about $75 million over a period of 5 years. In addition, industry provides one-to-one matching support. In a number of cases, even industry provides 1-to-5 matching support because they feel that this is very important and it will also help out to create more advanced manufacturing vendors for themselves. So let's recap now. So the fourth industrial revolution is much, much more powerful than the previous revolutions because it's going to impact our intelligence, our mind. We do not know how that will impact the society. But one thing we know that it will significantly impact worldwide the manufacturing industry. And as manufacturing is very important for America's security and prosperity, we need to make sure that we embrace the fourth industrial revolution. So during this talk, I gave you some background on what fourth industrial revolution is and the American strength which are fueled by this fourth industrial revolution. Then also I discussed how startups can take advantage of this fourth industrial revolution and thrive. So, the countries and societies which embrace the fourth industrial revolution will benefit. In fact, the World Economic Forum recently conducted a study. It was a worldwide study where they got input from the worldwide CEOs and industry experts in academia, science and technology, and also in other areas. And they use these 4 parameters to analyze as to which country will lead in the fourth industrial revolution. Now, this analysis was done by ensuring that only the countries which has a heavy manufacturing base is included in it. So they really included all the countries which account for 95% of the worldwide manufacturing output. So these countries were about 100. So after doing all this analysis, they conducted, one of the conclusions was that there's one country which has the potential to lead the fourth industrial revolution. And hold your thoughts. It is United States of America. And based on the worldwide CEO's input, they said that US will lead this revolution due to the strength in American economy and American R&D ecosystem, which we discussed and introduced before. So it is very fortunate news that America can lead this revolution. But we all know that for success, we need execution and not good fortunes. Good fortune does not bring execution. So we all, as a part of American innovation ecosystem, need to support hardware-based innovation in the United States, reshoring of manufacturing, reshoring of R&D, and supporting the country for its security and national prosperity. So we all need to develop a new mindset and a new tool set. So I recommend that we should add up this mindset of invent here, manufacture here, and export there by embracing the fourth industrial revolution and leveraging prudently the global supply chain. Thank you. Okay, so we have a few minutes left. I was told to finish exactly at 1 o'clock. So any question, please? Do we have a bikes, please? Oh, they're here. Can you, Ramesh, just go here or there? There's the one next to you right there. He's my friend, so he's not allowed to ask difficult questions.
Excellent presentation.
Thank you.
Congratulations. For a private company, let's say having a $1 billion of private assets in manufacturing, what sort of amount they would have to spend to embrace the revolution?
Okay. I haven't done a detailed research on that, but based on some of the input I have, it's approximately 10%. Right, yeah. So that's a figure you should be allocating in your projects and plans, right? Yeah. Okay. Anyone else? Yes. Maybe you can stand there. Right.
I would like to ask this question. We know right now the trade war with China is ongoing, and also America and China are doing the competition for 5G, and 5G is essential for IoT, right? Mm-hmm. So let me put it this way: if we lose the trade war with China, and also we lose the 5G competition with China, and do you think the fourth generation industrial revolution will still be taken a lead by United States of America?
Okay.
Or opposite?
Thank you. When I discuss America's strength, I discuss that our lead in emerging technology is only one of the 5 parameters. So I still feel that we'll have an edge. And the reference, the technology, I showed you a chart where 5G is of course important, quantum computing is important, and there are about 20 other technology which were listed there. So I personally feel that taking all these things into account, and which McKinsey done, World Economic Forum done in the 2 reports, and the Deloitte Corporation done, they also feel that America's strength are so high in all this other area, so America still will have an edge. But as I said before, these are the good fortune. But the good fortune do not provide success. We need to execute. So the problem is not all the trade wars and what's happening, in my opinion, but we need to execute. We have to develop this mindset that we need to invent here, manufacture here, and export that. That's my personal view on it. Thank you. Yeah. Okay. Your question, yes.
Are you aware about the urban workshop 3 miles away? It's the largest maker space in North America now. And how can we integrate what's going on there with what's happening here?
Okay. For that, you need to talk to Haley. She's the one. I'm one of the advisors here, but she's the one who manages all the processes and everything there. She's here, right? Yeah. So maybe you can talk to Haley on that afterwards. Okay. She's there, right? Yeah, right. Yeah. Okay. Thank you. Thank you. Anything else? We're almost there on the line. Okay. Yes. Please tell them. Yes.
I would like to know your opinion about the American government in the federal, state, and local levels. Do you think there is some areas of improvement of the government that to help this kind of generation of the manufacturing to leverage this process? Would like to know your opinion about if the government could improve some programs.
Right, yes. Good. That's a good question. In fact, that was one of the recommendations in the NSF report, that significant proportion of our R&D, federal government R&D of $150 billion is not really commercialized. So they want policymakers to develop plans and laws and processes which will help small and medium businesses and hardware-based startups to obtain funding from the government. So one of the ways they can do is that, and what NSF is recommending, is start translation institutes. And I feel that will happen. But if you want to know more about that, you can talk to me later, and I will provide you some other context on that, okay? But thank you. It's almost 1. And Haley, as you said, finish at 1 o'clock, so I'm done, okay? Thank you, guys.